equations. That means there's multiple equations working together. And this one's going to have 3 variables. So when we do 3 variables, most of the time we choose x, y, and z, but it could be any combination. And if we're thinking about that as far as graphs, you're thinking about something in 3 dimensions. X, y, and then z would be coming out of your paper. So we're talking about lines in 3 dimensions here. So here's an example of what a system of 3 variables would look like. And you might be asked if a certain point is a solution. So is this point a solution? Well, how do I know if a point is a solution to a system? Well, that means it works on all 3 equations. So if I plug that point in, it'll work. Now, just a note, since we haven't dealt much with 3 variables, this would be x, y, and z. We do them in alphabetical order, x, y, z. So I'm going to need quite a bit of room because I've got to plug it into all 3 of them. So I'm going to kind of scoot over to the side, and I'm going to plug into equation 1 first. So that would be -1 plus, whoops, you can't see that, 2 times y, so that's 2 times 2, minus 3 times z, so that's 3 times -2, and we want to see if that equals 9. So that's -1 plus 4, and then that would be plus 6. So 4 plus 6, that's 10. Yes, it works in the first one. Now, just because it works in the first one doesn't mean that that point is also on the other 2 lines. So 2 times x, so 2 times -1, minus y, so minus a 2, plus 2 times z, and we want to see if that equals -8. So that's -2 minus 2 minus 4. Yes. Now, just because it works in those 2 doesn't necessarily mean that it's existing on the other equation. So let's think about what that would be in terms of having these 3 lines in space. So could I have a point where these 2 are crossing, it matches those 2, but this line never touches them. It's way out here, and it doesn't touch either one of those. It's way up here, it's down below it, maybe, but it's not touching either of these points in space. Now, to be a solution, it's going to be the point where they all cross. So we need to test the 3rd equation, and that's -x plus 3y, so plus 3 times 2, minus 4 times -2. We want to see if that equals 15. So that's a 1 plus 6 plus 8, and it does. So yes, that is a solution. So if all 3 lines cross at a single point, then we will have a single point as a solution. Now, I could also have no solution where you have one that doesn't meet the others. I could have infinite solutions where these 2 are on top of each other, so all of their points match, but they only match one of the purple pin. Or you could have all 3 of them right on top of each other. So there's many ways that you can have these lines meeting each other. Whoops, I lost my page. Trying to get good examples. Here's my example. Okay, so the next thing is solving them. And most of the time, we're going to go back to the elimination method. The elimination method was when you added 2 equations together to eliminate a variable. Now I have three equations, so if I'm adding two together, I've got to pick two equations at a time. Okay, so let me label the equations 1, 2, and 3. So step 1 is we're going to pair up the equations. Pair up the equations to eliminate one variable. One variable. So I have to pick which variable I want to vote off the island. It could be any of them. For our example, I'm going to pick Z. Why? Just because. Why? No, not why. Z. Okay, so the first one I'm going to call pair 1. And I think I want to somehow combine 1 and 2. And I want to get rid of Z. So I'm going to look at the coefficients. That's a -4 and a +2. So if I take equation 1 just like it is, and then I take 2 times equation 2, I think that's going to work. So take equation 1 just like it is. So 5x minus 2y minus 4z equals 3. And I'm going to do 2 times equation 2. So I've got to multiply everything by 2. So that gives me a 6x plus 6y plus 4z equals -6. Now if I did this right, when I add these two together, I'm going to get x. I'm going to get something y, but my z's will eliminate. They're gone. Well, now I need pair 2 because I've got 1 involved and 2 involved. I have to get equation 3 involved because if it's a system, they're working together for a purpose. And I still want to get rid of z. I want to get rid of the same variable. So I'm trying to get rid of z. I'm going to pick equation 2 and equation 3 just for fun. So how about we multiply equation 2 by 3 and equation 3 by -2. So I'd end up with a 6 and a -6. And I excuse the noise in the background. It is raining really hard here. So 3 times equation 2, that's going to give me 9x plus 9y plus 6z equals -9. Then -2 times equation 3. So -2 times -2x would be 4x. -2 times 5y would be -10y. -2 times 3z would be -6z. And then -2 times 3 is -6. So I end up with 13x minus y equals -15. Now I have 2 equations, and they each have 2 variables. I'm going to call this one equation 4. I'm going to call this one equation 5. Because they're not the same as those. Can I combine these in a way to eliminate another variable? So step 2 is to solve the new system. So I have this new system of equation 4 and equation 5. And I want to combine them in a way that one of the variables disappears. I think I want to get rid of y. I think that's going to be the easiest one to do. So I have equation 4 here, equation 5 here. I forgot my bracket saying that they're working together. So I'm going to leave 4 just like it is. But I'm going to multiply 5 by And that would give me a negative 4y there. So 4 times 13 is 52. 4 times negative y is negative 4y. 4 times negative 15 is negative 60. That gives me 63x, those are gone, equals negative 63. So I end up with x is negative 1. I'm going to write that off to the side here because I'm running out of room on my page. Now I need to find y. So I can plug back into any equation to find y, but these are pretty good to use because they just have x's and y's. So I'm going to pick equation 5. And I'm going to plug in the x we just found. So that's 13 times negative 1 minus y equals negative 15. Negative 13 minus y, add 13 over, and I get negative y equals negative 2, or y equals 2. So I've got my x, I've got my y. This was a 3-variable problem, so I need z as well. So I'm going to look back at the top. I can pick any equation I want. Remember, if this is a solution, it's going to work in all 3. So it doesn't really matter. Let's just go with number 1. Number 1, 5x. So 5 times x. Then it had minus 2y, so minus 2 times y, minus 4z equals 3. So I went to equation 1. Negative 5 minus 4. That gives me a negative 9. Add that over, so I've got negative 4z equals 12. So z is negative 3. So the solution for this, I would write the solution as a point. It's going to be the point x, y, z. Let's do another example. Let's do example 3. That's a 17, sorry. Woo. I'll go quickly before I lose power or anything. It is really raining hard. So notice that in this system, y is already gone from equation 1. So if I could combine equation 2 and 3 to get rid of y, that would probably be a good idea. So in this one, y has a 1 coefficient. This one has a 2. I'd really like that to be a negative 2. So I'm going to do negative 2 times equation 2, and then write equation 3 just like it is. So negative 2 times x is going to be negative 2x, then negative 2y, then negative 4z, and that would be negative 34. Whoops, not yet. X plus 2y plus z equals 16. I'm going to add those together. Now I'm going to add them. That gives me negative x, the y's are gone, negative 3z equals, that's negative 18. So I'm going to call this equation 4. Now I can use equation 1 and equation 4 together as a new system. Oh, this one worked out so nice. Do you see why I'm saying this is working out really nice? What's going to happen if I add these together right now? the x's are going to go away. X plus negative x, it's gone. Z and negative 3z is negative 2z equals negative 10. So z is 5. Oh, how nice. How about this one? X plus z is 8. So x plus 5 is 8. So x is 3. What do I need to find now? Shelter, obviously. It is really raining. I'm going to use equation 2, I think. And it says x plus y plus 2z equals 17. So that gives me 3 plus y plus 10. Subtract 10, subtract 3, y is 4. So my solution is 3, 4, 5. How funny. It ended up being 3, 4, 5. That's really funny. All right. One of the ways we can use this is to find the quadratic function passing through 3 points. 1, 4, 2, 1. I'm going to change that up. Hold on. One, 3, 3, negative 1, and 4, 0. And remember, okay, so a quadratic function, let's use the form ax squared plus bx plus c. So each of these points is an x and a y. So I'm going to start with the first point, 1, 3. I'm going to plug 1 in for my x's and 3 in for the y. So I get 3 equals a times 1 squared plus b times 1 plus c. Let's rewrite that. 3 equals. Now notice the 1 is the only thing squared, so 1 squared is 1, so I have 1a. Then this would be 1b plus c. Plug in the next point. So y is negative 1, a times 3 squared plus b times 3 plus c. Notice it's only the 3 that's squared. So that gives me 9a plus 3b plus c. Last point, 4, 0. So 0, a times 4 squared plus b times 4 plus c. That gives me 0 equals 16a plus 4b plus c. I now have a system of equations with 3 variables. The variables here are a, b, and c. 1, 2, 3. Now if I just make one of these negative, when I add these, the c is going to go away. So I'm going to make equation 1 negative. So negative 1 times equation 1, and add that to equation 2. So that would give me negative 3 equals negative 1a minus 1b minus c. And equation 2 was negative 1 equals 9a plus 3b plus c. So I got negative 4 equals 8a plus 2b. Oh, that's nice. Now I've got to get equation 3 involved. I think I'm going to use equation 3 and equation 2. I'll make equation 3 positive and equation 2 negative. So I'm going to do negative 1 times equation 2 and keep equation 3 positive. So negative 1 times negative 1 is 1. That'd be a negative 9a minus 3b minus c. 0 equals 16a plus 4b plus c. So I've got 1 equals 7a plus b. I have two new equations, and I need to eliminate a variable. I think, let's get rid of b. Okay, so we have 2b here, or not 2b. Ha! What if I took this one and multiplied it by negative 2? So this times negative 2. So that would give me a negative 2. Negative 2 times 7, that's negative 14a, and then minus 2b. Sorry, I'm kind of running out of room, so I'm writing it over here. Negative 6. This is going to be negative 6a. Oh, how nice! A is 1. Well, now that I know that A is 1, I'm going to come back over here and plug in 1 for A. And so that'd be so B would be negative 6. Which equation would be the best one to go into to find C? Well, I kind of like equation 1. 3 equals 1a, so 1 plus 1b plus c. Now, I found a, b, and c, but this isn't writing it as a point. We were finding a quadratic function, but we know a, b, and c. So y equals ax squared, so 1x squared plus bx plus c.